All right, let me go back to sharing my screen with the presentation here. Okay, can you see this, and is it in full screen?
Yes.
Yes.
Yep. Yes.
Looks good to me.
Yeah.
Okay, great.
Yep.
All right, I'm going to jump right into this, and I'm glad to hear that Sarah, one of our senior apps engineers, is able to join. She's actually over in Brussels. It's quite late her time. Our company is based over in Belgium, and so Sarah, you can jump in. I'll go through the presentation, but you can jump in whenever I say something wrong, or maybe if there's a question that comes up that I can't answer.
Yeah.
But anyways, my name is Joe Ward. I'm the director of sales with epeas. I've been on board for a little over 6 months. epeas is a small company based in Belgium that's in an exciting area that I think will be very relevant to a lot of the work you're doing at InDesign. And I've had the pleasure of working with your company for many years from my past lives, and I really appreciative of Ron for setting this up, because I think, again, we have some really interesting technology in an area that's growing fast and has quite some innovation recently that I think, again, will be advantageous for a lot of the work you do. So EPs, if you're wondering what the name is, it's an acronym for Electronic Portable Energy Autonomous Systems. It's kind of a mouthful, but it kind of sums up what we do. We're a fabless company that we actually use TSMC as our primary foundry. We have our technology patent. We're all about energy harvesting. We have 30 employees now in 3 different locations, and we're pushing the limits of autonomy and edge computing. What we do is energy harvesting, and energy harvesting has been around for quite a while, but like most things in technology, it's getting better and better. What we do in our IC is much improved from what's been available in the past. And then our partners in the ecosystem, people that are doing PV cells or storage elements, that technology has improved dramatically. And so now the complete energy harvesting circuit can be very small, very efficient, very low cost, and in many cases, it'd be very justifiable to avoid having a battery or maybe having to replace batteries very often. And that is a big issue, as you probably know, for the battery operated products out there. And one of the exciting things about the business is that it's exploding right now, mainly because of IoT. There's so many IoT sensors that are coming on the scene, and this chart shows, you've probably all seen the marketing curves about how many sensors will be out there in the next 5 years, but it's tremendous. And of course, they're all wireless, they all need energy, and they all have issues with battery life and battery replacement and all that. So it's a very significant market. And so our mission is to provide scalable, sustainable solutions to enable massive deployment of fully autonomous edge computing devices. We try to make sure you can harvest more from ambient energy sources, consume less using ultra low power devices and technology, and enable seamless software technology for your applications. What we do, we have a device that's called an AEM, which is Ambient Energy Manager. The industry kind of refers to it as a PMIC, a power management IC. And we also have an MCU that I have one slide on. I'm gonna just tell you a little bit about it because it's not fully released yet, but I just want to give you a heads up on it. But in a typical edge device shown here at the bottom, you have a sensor or sensors of some sort, some processing, some communication, some type of radio, and then you have the power management. And this is specifically where we come in. We're the power management, but we work with the whole ecosystem. We have partners that are doing sensing and processing and radios and things. So we are quite knowledgeable and experienced in this area, and so we can help provide customers complete solutions. So this is our current portfolio right here. We have these AEM devices that and there's one available for each type of energy source. So solar or photovoltaic, which we call PV cell, is the most prevalent. That's most applications are using lighting of some sort. And we have this actually 2nd generation device in production today for those applications. We have a device for thermal, for doing energy generation from thermal applications using TEGs and such, and that's this device. And then we also have a device that does vibration and RF energy harvesting. And those sources are AC sources, and our device requires a DC voltage. So you do require an external rectifier for both of these applications. And then an RF, you do require also a matching network so that you can match the RF signal with the antenna and such. So, but these are all the energy sources that are generally available out there. And as I mentioned, PV cell is the most popular. We're seeing a fair amount of thermal and vibration, and RF is kind of the up and comer. A lot of companies are investigating ways to harvest the RF energy that's out there everywhere. And it's, as I know you know well, I've done some RF work with your group in the past, and I know you know RF extremely well, but it's tricky, it's complex. There's losses in the air, there's losses and so proximity is important, but if it's done right, it can be very effective, and you can harvest a lot of energy through RF. So anyways, this is our portfolio, and just a quick example of applications. And I think you've done work in these areas, but tracking, monitoring things, predictive maintenance. Actually, one of my biggest customers is doing electronic shelf label. They're putting these in retail stores and RF through RF channels, updating the displays. So some really exciting areas, and it's in every market segment you can think of, because they all are, there's so many different battery operated sensors in every market segment. One slide on our microcontroller. It's kind of under wraps until the year end, but it's going to be an ultra low power ARM based MCU that'll fit extremely well in these type of applications, low power sensor applications. And so if you want to get some advanced information on this, let me know. I can get an NDA in place, and we can kind of give you a little bit more information on what we have in this area. But for right now, we're all focused on the PMICs or the AEMs. Okay. Again, I know InDesign knows IoT extremely well, and you know that IoT devices are deployed everywhere to measure sensing and to measure things and to monitor things and to track things. And I'm sure you know that battery replacement is a major headache for most of these users. And what we're going to propose, what we are all about, is showing you how energy harvesting offers solutions to these problems and removes these cost and replacement issues. Obviously, having a energy harvesting circuit removes maintenance costs from replacing batteries. It extends the life of the product. It reduces storage volume. But actually, a lot of people forget that you can add features if you have some extra power capability. So you maybe could add an extra sensor or two, or you could transmit on your radio, every 15 minutes versus 3 times a day that you were restricted because of your power budget. I mean, there's a lot of things that you can do if you had a little extra power, and it's something to consider through energy harvesting. All right, what is it? It's all about harvesting energy from ambient sources, and then storing it, and then using it to drive a load. And I mentioned these 4 different sources that we support, and it's the AEM fits right in the middle, and there's a very important role we play in managing the power for the whole energy harvesting circuit, but also extracting the maximum power from the harvester. I'll talk about that a little bit later, about what that means. But if you look at how the energy comes through these different sources, it's usually a parabola type of curve, and you want to make sure you're harvesting the energy at the maximum power point so you're as efficient as possible. And that's something that we have a very unique approach to doing. You also want to start from, do a cold start, which is from 0 volt nodes at as low energy as possible, so that you can start driving your circuit and start storing energy. So we have extremely good cold start specs, as low as 3 microwatts of energy to get this thing turned on and start boosting energy to your storage element and to drive your hardware. And just efficient energy transfer, and that's something we're really good at, and I'll tell you more about that too. So this just actually reiterates some of those points. Why do you need something between the harvester and the storage element? So that you can extract the maximum power. You can start at extremely low power points. You can protect your storage element from overcharge or over discharge, and you can supply regulated voltage to your application. We've got 2 LDOs that are supplying efficient regulated voltage, and I'll tell you how that all works. But these are all integrated into our device. It's very easy to use. There's no software. This is an analog device. There's just some configuration pins that you can configure depending on the type of storage element you're going to use. If it's a super cap or a rechargeable battery, it's just a few configuration pins to set up, and it's off and running. I'm talking fast like I always do, but if you have any questions, please just jump right in, and I want to make sure that I'm not missing anything. So just cut me off when you have a question. So again, this device fits between the harvester and the storage element in your load, your hardware, and it has very low leakage, 400 nanoamps, which makes it very efficient, and that's very important in this type of circuitry. I mentioned the cold start already, 3 microwatts or 380 millivolts. The MPP tracking capability. We protect the storage element by not overcharging or over discharging it. And we have the 2 voltages coming out, high, that typically drives a radio, and then the low voltage typically drives an MCU or some circuitry. And that's what it's all about. Our goal is always to replace a battery in these applications, which we often can do, but sometimes we can't, just because maybe the energy source will be in the dark for extended periods of time, or customers need to have it guaranteed on. So there is an accommodation for a primary battery. And so if several applications will still put on a battery, often it's much smaller than what they were originally intending, but they can use a primary battery just to guarantee that they have a backup if in an event that there's no energy coming in and your storage element is empty. So that's another feature of our device. I mentioned storage elements. We work with all different types of storage elements. We have partners in these areas for third-party companies. So if you have any questions about it or would like referrals or performance information, we can help you with that. But again, we support caps, super caps, and all sorts of rechargeable batteries for the storage element. And again, it's very important to make sure that source is managed properly so it doesn't overcharge or over discharge. And again, we manage that. So just again, the product summary, and to dive in just in a little bit of detail, you can see the architecture of the device, the block diagram at a high level over here up in the top right. And it has the cold start circuitry, the maximum power point transfer, the interface for the harvester, and then the boost circuitry that is up to 95% efficient. It's very efficient boosting. We have a buck and a couple LDOs. We have the feature for the primary battery, and the interfaces for the storage elements, and then the LDOs for the outputs. So it's basically it. So now, if in a PV cell application, you would have the PV cell hooked directly to our device. There'll be 7 passives required, which is a very small bill of materials for this type of application compared to some of the alternatives, and then a storage element. So that's the complete energy harvesting circuit. And I've been doing some quoting for some customers that, and for high volumes, like 1 million units, you can get that for under $2. Our device, the PV cell, the small passives, and then a super cap. So just to give you a ballpark example, for a high volume application, for lower volumes, it might be maybe $3 to $4, depending on the size of your PV cell, the size of your storage element. But it's become much more affordable. And yes, batteries are lower priced, but when you start considering the cost of maintenance, replacing them, the disposal issue, especially when you're trying to scale up hundreds of thousands of these things, it's many customers are now recognizing that this is a very advantageous way to go for many reasons. All right, we're just moving along. So to dive in a little bit on the devices, this is the solar device, the PV cell device, the 10941. Yeah, I already showed you this picture. I mentioned the 7 passives. You can see 2 inductors and 5 capacitors listed here. The device today is available in a QFN, but it'll be available this year in a CSP package. Very small. We're targeting that for ultra small packages, applications, including wearable devices. This device is with the CSP will work very well in those type of applications. I mentioned some of these specifications, you know, the inputs, the cold start, the buck boost efficiency, the MPP tracking. I have a slide on that in a minute, but I would tell you how we do that. And then I mentioned the leakage current, the primary battery option capability, and then the high voltage and low voltage outputs, storage element protection. One of the things that I'll mention a few times during this presentation is we have great documentation. We've got full data sheets. We've got really nice eval boards for all these devices, and they come with a quick start guide as well as a more detailed user guide. We've got some really nice app notes. So lots of documentation for you to kind of assess what these are all about and how to use them and the type of energy you can harvest and what this might mean to your applications.
Hey, Joe, I've got a quick question.
Yes, sir.
So I'm a firmware guy. When I look at that last slide and I see the high voltage output is 80 milliamps,
Yes.
what kind of wireless technologies can run off of 80 milliamps, just to give us a scope of what you might connect there?
You
can maybe.
Yeah. Sure, sure. Yeah.
So you can go with LoRa, you can go 6Fox and BLE, that kind of communication. Of course, if you would like Wi-Fi communication, then it's mostly 200 milliamps than 80. NB-IoT should be working also, 6Fox, Zigbee. So I would say most of the radio used in the IoT world, but in case you don't want to use internal LDO, you can actually disable both of them, of one of them, or neither of them. It depends. It's really up to you. You can enable or disable them. If you disable them, you can put an external DC-DC converter from the storage to your device, and there it's up to the DC-DC converter use. Actually, we have a mini eval kit which has a DC-DC converter, a buck one connected to the storage that can be used to supply Wi-Fi communication, or I don't know. Yeah, I don't have another example, but
that's great. That's some good examples. Thank you.
Okay. Sarah, while you're here, maybe you could just walk through this slide talking about the maximum power point tracking, because I think it's important.
Yeah. So when we talk about harvesting energy from ambient energy, of course, we are talking of really low power, and we will actually be also working with low voltage. So as Joe mentioned, we have the cold start, which is one of the features that enable the AEM to start collecting and harvesting the energy at from 380 millivolt, and it only needs 3 microwatt to get started. So those are the conditions for the cold start. But then when we are working, we would like to extract the maximum from the, let's say, small available power. And there we have a feature called MPP and T for tracking. So we track the maximum bound. And the maximum pound, actually, it depends of the harvester. So if we look here at the curve from a PV cell, so you can see the green curve, which is the power for the PV cell under different luminosity. And you see that it's like a belt. So you have a maximum pound, and we would like to work there. Working there means that we have to work at a defined voltage, which is called here VMPP. And what we do with the AEM is actually get disconnected from the harvester. So the harvester will achieve its open circuit voltage, VOC here. We measure it. We apply a certain ratio, which is defined by the technology of the harvester. This is something you will find in the harvester datasheet. We apply this ratio, and then we have the VMPP, and we know the reference for the DC-DC converter. And this is actually happening each 5 seconds for the AEM 10941. The frequency might be different for the other AEM in the family, but the idea is always get disconnected around 1% of the time, so we don't lose too much power, so that we can, at a defined frequency, adapt the working voltage and be sure we are always extracting the available power. So even if the light changes, each 5 seconds, we will adapt the working voltage.
Great. Thanks, Sarah. Again, just a simple diagram of our device and the 7 passives I mentioned. You can see how they're identified, what their role is, and then on the left you see a chart that just shows how when the voltage in gets to a certain level, we boost up to VBAD. Then there's a buck and the 2 LDOs, and that's the fundamental architecture of the device. So I just one sneak preview for you. We have a next generation device coming out later this year that is slightly more advanced. So if you're interested in this, I can get an NDA in place and we can share with you more details, but it'll be, just a little bit lower leakage, a little bit more efficient, a little bit better cold start. It's a little bit more advanced. And so, I mean, the 10941 is an amazing device right now, and it's working perfectly in many different applications. But this one is something that we're targeting for a little bit lower power, like wearable devices. Anyway, it's coming out in the CSP package I mentioned. Only 5 passives. So again, if you're interested in hearing more, let me know, and I can we'll get something set up so we can give you more information. So this is the second device that you saw on the chart. This is the device for doing thermal energy generation. So again, the harvester would be some type of TEG, a thermal energy generator, and it's fundamentally the same architecture as the other device. You can see the architecture blocks are the same, and then the passes required are very similar, but just some minor adjustments on the front end. Sometimes people want a lower cold start for thermal applications. So we have accommodations to be able to do that with some options. But other than that, it's fundamentally the same. Again, data sheets, eval boards with user guides for this product. And thermal is kind of niche-y. You have to have obviously a certain temperature gradient to be able to harvest enough energy. But if you have that for your end customer has 10 degrees or more, roughly speaking, they should be able to get a reasonable amount of energy. So again, this is the kind of thing we work with customers to determine. They come to us and say, this is the application and this is kind of energy we're looking at, and what can we do? And so that obviously we love to partner with InDesign on these type of things. And if you have opportunities and we've got a resource pool of people that have expertise in this area, we'd love to help you make the assessments and do the analysis to determine if this makes sense for the different applications. So
hey, Joe, I have another question.
Yes.
When you say cold start, is that the voltage and power that's coming in from the harvester, or where is that cold start power and voltage coming from?
This is what you need at the AEM input. So this is what should be available at the harvester output.
Right, so the PV or the thermal energy,
yes,
if you get some of that, as soon as you get above a threshold, then this device can start working.
Yeah, you should be above those 2 conditions. So
all right, thank you.
380 millivolt and 3 microwatt.
Thank you.
Okay. Again, just summarizing the devices, this is the vibration device that I mentioned earlier. Again, core is the same as what you saw earlier. Again, new eval board for this and all the documentation. And then RF, this is the up and comer. We're getting a lot of interest in RF. My largest customer in the US is using RF for doing ESL, as I mentioned, and other, shelf labels and other different products. But it does require, it's RF is complex and you need to have an external rectifier in the matching network. But other than that, it's fundamentally the same. We do have eval boards for the different frequencies for sub-gigahertz, for 868, which is more Europe, or 915. And then we also have a board for 2.4 gigahertz. So and we have a really nice app note that Sarah put out for doing RF energy harvesting. So it's something that we could probably spend this whole session just talking about RF energy harvesting, because there's a lot to it. But we if you're interested, we can set up get you the information, get you an eval board, and set up some one-on-one dialogue to go into a specific application or to show you some feasibility analysis and what we can do in this area. So, but it's exciting. RF harvesting is kind of where I see it's the up and comer. I mean, to reiterate, PV cells by far the most popular. Thermal and vibration are a little bit nichey, but RF is growing fast. So, and we do have, I mentioned the eval board that's out. We have one of these for everything, but this one's one of the newer ones, and you can see the combinations here. We do also have the 2.4 version, 2.4 gigahertz. So yeah, so it's again with full documentation, so easy to tinker around with. And again, what I would be very interested in doing, because I'm looking to make sure InDesign has full capabilities in energy harvesting, and which I think would be advantageous for when you talk to your end customers. When they're coming to you and they need a battery solution, and you say, hey, have you thought about, we could make this battery life 5x longer, or we could even maybe get rid of the battery. It's kind of a feather in your cap that you have that expertise. And so we want to make sure you're knowledgeable and have access to the tools and documents. So if you would be interested in having some of these eval boards around in your lab, I would be more than willing to make that happen. And so one other thing so this is just a general question, general information about energy harvesting your device. And obviously when we engage a customer, we want to understand their environment, so what kind of energy sources do they have access to? We want to understand their device consumption. And then that helps us to direct which AEM. Then we can work on power for the whole solution. And then the end result will also tell us what storage element they can use, what size is best. Sometimes, the environment's limited. They might have a size constraint on the PV cell, or just a limited amount of power they'll be able to generate. So that might dictate, how much they can drive the load, how often they can transmit on their radio, for example. And then, or sometimes they might have limitations on the storage element. So there's kind of three ends to this, three parts of the triangle, and we can massage them depending on restrictions on the application. So this is something I wanted to tell you about. It's a neat little demo unit we use, and I'm finding that partners of ours like InDesign like having these around so they can show end customers. But basically, it's about a 2.5 inch by 2.5 inch by about maybe a 1/2 inch thick little demo unit. It's all encased. There's got a PV cell on the front, a couple sensors here for humidity, temperature, and lux, light intensity. It does have a super cap in there, but no battery, and it transmits by different means. It takes this data and transmits by Bluetooth or LoRa or Sigfox to your phone, and you can register this data. And again, it's a great show and tell. So people are asking you about energy harvesting and how it would work. This is just one way to demonstrate it to them. Say, take a look at this. This is a no battery thing that and so we can make these available to InDesign if you want a couple around to show and tell. Let me just show you a little bit more about it. It's got this little board in there that basically just has a sensor, a PV cell, a super cap, and our device. And so it's pretty simple. And you can, let me just show you a little bit about the device itself. So we looked at the size constraints we had, and we worked with a company on this application that calls 3G Solar, one of our many partners in the PV cell area, and we looked at their power curves, and we realized that we needed 220 microwatts, and so we determined that the size of the PV cell would be 35 by 50, and then we were able to determine that the storage element we needed would be this. We use this partner storage, a super cap, and you can see the size there. So this is all determined through going through the information I discussed earlier that that allowed us to determine what size PV cell, what size storage element, and what kind of load we wanted. So long story short, with below 10 hours of like indoor lighting, 300 lux, which is kind of typical for indoors, we're able to harvest and store enough energy to supply the device 24/7. So, and again, you can see the little charts here that measure the temperature and humidity and some of the product, oh, here it is. I'm sorry. And as I mentioned, we have different versions of this. So we can work with LoRa or Sigfox or Bluetooth. And so again, if Ron, if anybody has any interest in this, I can get some of these over to InDesign, and they're pretty straightforward. So I've been focusing a lot on PV cell because it is the most popular, but I do want to mention thermo, heat generation and vibration a little bit more. And this is one quick slide on doing a temperature sensor with using this TEG. This is, again, we work with different partners in this area. Depends on the type of temperature measurement you need, the type of gradient. If you're going to be indoor or outdoor, there's different options for different partners. But for this one application, we were using this company RMT, and this is a pretty small TEG, and we use this storage element for this application. And so this is the kind of thing that if you have some interest in, we can share with you this kind of data, how we went through the data to pick this different storage elements, the trade-offs we see with the energy harvesters and the storage elements. So we'd love to share that kind of information with you if you're interested for any of these different types of applications. I think I showed this one already, examples, so I'm going to skip that. I keep talking about our partners. It's a huge ecosystem, and it's great because there's been a lot of advances in this technology, and everybody's got their niche. If it's indoor or outdoor, or if they need flexibility, if you have size constraint, if you need environmentally safe so that you can deal with harsh conditions, and there's different partners that use different technologies that excel in different areas. So this is just a sample list of the partners for PV cell, for thermal, for vibration, and then for the storage elements. And again, we've done a lot of research in this. So if you would like some advice or so you see some test results, we can work with you on that. All right. So this is kind of, again, going back to the fundamental thing. How do I size my elements? We have different types of eval boards, but basically these smaller ones allow you to pick any type of harvester, your storage connector, and then your application. Well, that's the end of this presentation. I'm going to slip into one other one real quick. Oh no, we still have time. I still have 20 minutes. Okay, good. All right, let me show this one. And actually, since Sarah's on, Sarah, maybe this, I don't know if Sarah, if you want to show some slides on some use cases, but I had a presentation I was ready to share that, let me just show it here, and you can decide if this is a good one for you or not. So can you see this screen, or let me try resharing it? I think I have to reshare.
Okay.
Yeah.
I was not seeing anything new. So.
Yeah. Oh.
Okay. I don't know if because you already discussed maybe the ambient the AEM family. What I can add is that, so as Joe mentioned, we are surrounded with partners. The idea is always to get and find new one, because we want to be able to provide you technical solution for your environment, for your device, and of course we need to get and to be in touch with the best technology for the PV cell, TG, the electromechanical harvester, or even the antenna. So this is something we can, of course, provide you through support or any study we can make around a use case you have. As Joe has mentioned, so those are different. I don't know if you already mentioned both of those examples, but the demo we have been building is really just to provide an example. Build it with a demo BLE communication, LoRa, 6FOX. We will have more coming, NB, IoT, Zigbee, because we just want to show you what can be done with indoor light. So the PV cell we are using here is really dedicated for indoor light, and we are getting 200 microwatts below 300 lux. So we can make it bigger, smaller, depends where your device will be located. We can also help you to get another PV cell, maybe more adapted for external, for outdoor light, or we can also help you to find a TG or mechanical harvester if you would like to harvest from vibration or difference of temperature. Maybe we can just stop there, Joe. One thing that is really important talking about energy harvesting is the energy balance. So what we need to help you to move on is an idea of what you try to supply. The sensor, the microcontroller, the radio, it could be just average number or a rough idea of what will the device be consuming, because actually this will help us to study the energy that must be stored, that must be boosted, and the power that must come from the harvester. This is how we build and how we can help you to get as quick as possible to the test and to the design. This is what we have been doing to build our demo, and we still use, let's say, this flow to build our new demo coming on. I don't know if you have any question about either the partners we have or the AEM itself, the behavior, or we can also provide technical support. So meaning it could be like a technical presentation about the AEM, the configuration, the behavior, and that kind of stuff if you would like to go deeper and use an eval kit. So yeah, we are. Yeah, here is just an example of what we do, meaning energy balance, energy study, because it's actually what is the most important, to be sure that we will get enough from the environment and be able to supply your device. This is the most important, but it's not complicated. It just requires some details to move on, and then you can start testing with our eval kit.
Okay. So that is, we can dive into a little bit more detail, but that was really the high level overview I wanted to provide. Are there any questions that we kind of threw a lot at you? But is there any questions or anything that you would like to see in here in this last few minutes? We can kind of we could if there's any specifics about solar or RF energy harvesting, or if you're
maybe I can just have a word. So about RF,
yes,
we don't have so we use an external RF rectifier with RF diodes, and we also add a matching network. This is external to the IC, so it could be adapted to another frequency. We have been focusing first on the 868 and 915 megahertz band. Now we have also a solution for the 2.4 gigahertz band. We can adapt it to another band. Actually, you just have to change the matching network. This is something we can do, but this is something that can also be done by some expert you have. It's really external, and we provide this as a support to provide complete eval kit, where you just have to connect your antenna. But if you have any question about that, we are open also to discuss any design there.
So I had a question on the RF. So are you just using ambient RF energy, or is there actually a transmitter? Like if you were doing a store and you were trying to make sure that you had all of your sales tags, be able to get some energy source, would you be normally just trying to harvest ambient energy from, the 900 megahertz band where there's other devices that are transmitting on that band, so you're trying to harvest that? Or would there actually be a transmitter in the store that's putting out a certain frequency that you're trying to receive?
So actually, we could be harvesting from any RF signal. The thing is that we need a certain level of power to get started. So like we need 300 microwatt and 3 microwatt and 380 millivolt at the input of the AM. If we add the RF rectifier and the matching network, we need minus 19 dBm at the antenna to get started. This is true for 868 megahertz, 950 megahertz. For the 2.4 gigahertz, we need minus 15 dBm. So if you can get this in your environment because you have a lot of communication, because I don't know, let's say in train station, you might get that in some area, then the AEM will be able to get started and harvest. But if you don't have that amount of power, the AEM won't be starting. And I know that a lot of people are asking to harvest from the Wi-Fi, but it's a good thing for our body, but the Wi-Fi, it's not made to emit power. It's made to emit data. It also has some duty cycle. Actually, it can only emit 10% of the time. So you have to be sure that in your environment, you will get the minimum amount of power. And for that reason, for the moment, we really first focus on RF energy harvesting, but with an emitter, with a dedicated emitter that can emit the amount of power you need for your sensor around. So this is something that OSIA has been designing using our AEM3940 in the receiver. They have been working on the emitter that point out the power to where the label is, and they can harvest from there. But yeah, to be honest, for the moment, I would say it's easier to use dedicated emitter because you control the power that is emitting, and you are sure that you will get enough to get started. But if you can measure and be sure that in your environment you will get this minimum minus 19 dBm, it should be working.
Okay, thank you.
Sarah, I noticed that in your reference design, you have looks like two different RF paths with maybe two different detector diodes.
Yeah, it's actually one for the luminosity and the other one is temperature and humidity. And we also have an accelerometer.
No, I was talking about your RF. Joe chopped up a.
Sorry. Sorry. You mean two SMA connector?
Yes.
Okay.
The two RF paths.
Yeah, actually, it's because the input power range we first targeted was minus 20 up to plus 10 dBm. And when we started to make the matching network, we saw that it was not possible to get the best efficiency over this entire input power range. So we split it. You have a matching network that has been designed from minus 20 dBm, so starting at minus 19 up to minus 5 dBm. And if you have input power above minus 5 dBm, it's better to use the other matching network. Actually, if you look in the data sheet of the AEM3940, page 22, you have a graph with the two efficiency curve from the antenna to the storage element. So this includes the RF rectifier, the matching network, and the boost converter in the AEM.
Okay. And Joe, is it possible to get a data sheet for that part and documentation?
You bet. And who's this talking?
Rhodes, you could just send it to Ron Kern. He'll make sure I get it.
Okay, perfect. We'll do that.
It's in page 22. I'm just looking at the data sheet right now, and you also have a guide around to help you. But this is something that if you know the input power you will get, let's say you know that you will get minus 10, we can still optimize the matching network to be better at that input power. Here we were targeting input power range.
Okay, thank you.
Sure. Okay, any other questions? Well, perfect. I think we'll wrap up now then. You see on the screen, hopefully you can see on the screen right now, my email address. If anything comes up, you have any questions, would like any other documentation, eval boards, or those demo units, please feel free to contact me. Oh, and by the way, I want to introduce somebody who's on the line. Brian Judici is on the line. He's with our local rep. I think some of you might already know him, but he's our representative for InDesign for your market. So he can help you out with any requests.
Yeah, I appreciate that, Joe. Thank you very much. I think I do know some of the guys on the line from InDesign. Yeah, please feel free to reach out to me locally. Obviously, between Joe and I, we'll do our best to support you.
You bet. Fantastic. All right. Well, I really appreciate everybody's time. Enjoy the rest of your day. And Sarah, thanks for joining so late your time.
No problem.
Thank you.
Thank you.
Thank you.
right,
Have a
okay.
good day. Bye.
Thanks a lot. Appreciate your time.
Thank you.
Bye-bye.